Hi everyone. So in this computer networks lecture series, today we are going to discuss about the topic on Unicast writing. So which is a topic from Unit 3. We already know that. So let's we move on the session. Before that, I'll introduce myself. I am Logesswari from RMDEC Engineering College, working as an assistant professor in CSE department. So as we all know, what is mean by a routing? So routing is an important one of the main functionalities in the transport layer. With the help of the routing, we can able to route our data packets in the optimized way. So for that, in order to do that, we need some protocols that is said to be the routing protocols. We have two different variations categories are there. One is it is classified. Routing protocols are classified into two types. One is intra-domain routing, next one is inter-domain routing. Coming under the point of intra-domain routing, we have a distance vector routing and the link state routing. And then inter-domain routing, the example is the path vector routing. So the working protocol that what we are using is the RIP, that is routing information protocol. For the link state routing, we are using the protocol called as OSPF, stands for Open Shortest Path First Protocol. So let's we discuss what is intra-domain, what is mean by inter-domain. Intra-domain means it is used to route the packets within the network. So it gives us an idea how to route the packets within the network. So that is said to be the intra-domain. What is meant by inter-domain? How to route the packets from one network to another network. That will be given in the path vector routing, which is also called as the BGP. Okay, so in this lecture series, I'll be discussing what is meant by distance vector routing and the working concept of the distance vector routing. So in the further coming lecture series, I will be explaining what is meant by link state routing and then the working concept of OSPF. Okay. Okay. So what is a distance vector routing? So it is very simplest form of an routing algorithm. It tries to find out the least cost with the minimum distance to reach the particular node. It tries to get you the node which is having the least cost. So it should be the via for to reach another nodes. So that is the main characteristics behind distance vector routing. So the topics which we are going to discuss in this section include how to initialize a network table sharing, how to share a table, how to update a table, when we have to share a table, what are the different problems are there in the distance vector routing. So before going to the topic, I'll just give you an idea so how it works. Like in basically in distance vector routing or in any other kind of routing algorithms, it will create a table. Each and every node will create a table or maintain a table. Based upon the table only, it will update the nodes of the neighbors and then will disseminate their own table to other networks. So this is a main concept behind not only distance vector routing, in all other distance vector routing algorithms. Okay. So let's move on to the initialization. So how to initialize a table? As you can see here, once again. Okay, fine. Once again. Okay. So as you can see here we have 5 nodes, right? A, B, C, D and E, right? So each and every node is maintaining a table. So in A's perspective, we can see that A is maintaining a table. So to which node it is, 2 stands for the destination, cost to reach the particular node, next stands for via through which node I can able to go to the particular network or a node, how to reach the particular node. So that is said to be the next node. Basically the cost to in the S perspective we are calculating, right? So from A to A, so obviously the cost is 0 only, and then the neighbors are A to B is 5, and then A to C is 2, and then A to D is 3. But I don't know how to reach E. Okay, right? So initially, actually what I'm showing is that it is a final table, but initially it won't be like this. Initially, if I'm a new node to enter in this particular network now, I don't know how to reach the particular node. So it will be considered as infinity only. Okay, it will be considered as infinity. I'll show in the next slide. So see, so this would be your initial table. This could be your initial table. As you can see, A couldn't able to reach E. Why? Because actually there is a way, but if it is a new neighbor means it's very difficult. Okay, so A to one second. So A to E is hmm. So A to E is initially the A to E's value should be infinity. Why? Because it is not directly connected. Likewise, I am going to maintain a table for each and every node. In E's perspective, coming to the point of E's perspective, A to E is unreachable, right? But so it is said to be an infinity. But A could able to reach other nodes and all. So that is why it is said to be. So in this way, each and every node will maintain the table, and then they will disseminate the table to the neighbor nodes and update their table. Okay, so when this particular table will be disseminated, so there is a timer. There are two ways the each and every node will pass this information to other neighbors. That is on periodic update or when there is any emergency situation. So like for every 30 seconds, each and every node there update their own table or pass their own table to the neighboring neighbors. Apart from that, if there is any problem in the network link, if there is any path change in the network link, on the time also it will pass it. Okay, let's we move on to the session that how to calculate these two nodes, how to calculate the values. So here for sake of understanding, I have taken the node from A's point of view. You can take whatever as you like, but for the sake of example, I have taken only the A's perspective, how A is calculating or how A is updating their nodes. Because A is also having an one node which is an unreachable, that is E. We tries to eliminate the E value, infinity value. Okay. So this is the cost. So why I am taking the cost from received from C? Because A is having so many neighbors. Among all the neighbors, which is having the least cost, as you can see, A to C is having the least neighbors, that is 2. That's why I am taking C as my node. Through this node, I will be passing the information. So 2 and then cost. So you can see that A to C is 2. So these are the information which is received from the C value, and then I'm going to compare. So A is modified. What I'm trying to do is that I want to reach all the nodes via C only. So if I want to reach A to A now, A to C is 2 and C to A is 2. 2 plus 2 is 4. That's why it is updating as 4 here. As well as for uh, A to B is 5. But my intention is I want to reach all the nodes via C only. So A to C to B. So 2 plus 4 is 6. So likewise I am updating all the nodes. So this is a new modified table, and then I am comparing with A's old table. Based upon this comparison, so which cost is lesser, I will take that cost as my cost for my new table. So as you can see, initially A to A cost is 0 only. If I see C as my intermediate node, it is 4. It is somewhat higher row. So I won't take that value, and then I will omit it. And then A to B is 6. But old table itself A to B is 5 only. So I am taking that value. So our main intention is here C is E is discovered. A to E is 6, here infinity, which one is higher? So sorry, which one is lesser? 6 is lesser. So I am taking, in this way I am discovering the path to that unreachable nodes. So and then unreachable nodes, so how could I reach the node? Via C only. So in this way it is calculating or updating the this table for each and every node. So this is said to be the distance vector routing. So here itself we have, what about if there is any node fails, what will happen before failure? So if there is after failure, what will happen? A updates its table to the if the, as I said earlier itself, there is updation will be occur in two ways. One is the periodic update. Next there is a next if there is any in a change in the network, on the situation it will update. So you can see that A is the link has been broken, automatically it will be sending the update information to the neighboring nodes. So likewise a particular node will be link has been changed to infinity here, in the sense it is said to be an unreachable nodes. So these are all the main working concept behind the distance vector routing. So in the next series we will be discussing about the link state routing. Thank you.